Hi guys, hope you all had a restful 3-day weekend, or at least whatever you did that you found productive and got some good value out of it. Want to go ahead and share some announcements before we get to start in today's topic, because today's topic is definitely going to be one of those dry ones. There's just not any way around it. It's an important one, but it is definitely dry, and I'll try to add a little bit of substance to it where I can. But after today's lecture, we will have our Chapter 3 homework on Friday. It's only a 2-day turnaround, so you will want to make sure that you're aware of that. Please be aware that when you're doing the homework, to make sure you're answering the problems and not the discussion questions. This comes up every semester, and I'm not surprised. Generally, when it happens, I'm just like, okay, that was unintentional, and I'll grade it fine. But please try to answer the problems, as those are the ones that I find value in whenever I assign them. That will come up later, that I will assign discussion questions instead of the problems. And then later on, I'll assign both discussion questions and problems. So you need to get into the habit of making sure you identify which one's which. All right, and then we have some announcements about this coming week. So for those of you who are accounting majors, you will want to, if at all possible, try to attend Meet the Ferns this coming Friday from 10 to 2. This is going to be a great opportunity for you to build your networks and find potential employers. The one thing I always hear from potential employers, well, first of all, a lot of them are former Truman students, the ones who come and recruit here for Meet the Ferns. So you'll get to hear stories about some of your professors that you like, and even some that you don't like. So hopefully there are not that many professors that you don't like, but you can hear stories about them, and they'll tell you details about their own time here. But from other employers, the people who are at the top positions, they are constantly saying, we want more Truman students. And so it's just a great opportunity for you, regardless of what your major is. And I'll talk about the ones of you who are not accounting majors here in just a second. But if you're an accounting major, this is a good opportunity. Even for some of you who are not accounting majors, this may be an opportunity for you to reach out and some possibilities. It's primarily designed for accountants, but I thought I'd mention it just for everybody. I want to mention that this is the extra credit opportunity, but obviously, if you don't feel that you're going to get value out of this because you're not planning on going to a career in accounting, there is an alternate to this one. That is the Career Expo on September 26th. That will be from 11 to 3 p.m. I'll try to remind you of that as we get closer to that. But if you can't attend this one, or feel that it's not appropriate to attend this one, that's your other opportunity. Now, again, if you attend both, good on you. I'm only giving you credit for one, but it's the extra credit opportunity. Please keep in mind that even though it's extra credits, that you do need to complete extra credit assignments in order to be able to opt out of the final exam in this course. Plus, it's just free points. I mean, who does not like free points? Like if you walked in Taco Bell and they say, would you like a free taco? How many people are going to say no to that? I would. I don't like Taco Bell. But how many people else in this room are going to say no to that? Okay, there we go. And then a couple of items I also wanted to bring up. Before the Meet the Firms, there will actually be an information panel held by Beta Alpha Psi. This is basically about accounting careers information. And if you want to attend this, this is something that you could use for your professional interaction assignment for this course. I would encourage you to do that. If you have any questions about what it is that you want to know about what it is that the career looks like and what the expectations are. That's from 4:30 to 5:30 on September 5th. So this tomorrow, I guess. Yeah, time flies when you're having fun, I guess. So please be aware of that. And then also coming up next week, next Wednesday, over in the Innovation Lab over in the library, there's going to be a presenter, a computer science major, a former computer science major for the True Entrepreneur Speaker Series, Cody Sumter. And that will actually be immediately following this class on Wednesday. So we'll get out of doing our first NetSuite assignment, and then you can go and watch that, assuming you don't have a class immediately following. If you do, I can't help you there. This will also be something that you could use for your professional interaction if you're interested in this. Now, if you want to attend both and you're just like, but I can only use one for the professional interaction, do yourself a favor and attend both of them to expand your knowledge base, learn some more information. You only have to do one for your professional interaction, but there are opportunities are available. Both opportunities are available to you. And I encourage you to do that whenever you find something interesting. So yeah, that's going to be what's coming up in the future. And so please keep that in mind. I'll try to update you on this over time with these, but I highly encourage you to make sure you monitor your emails. Dr. Caden, who's the chair of the business and economics combined departments now, she's really good about sending updated emails as long as you monitor your email for announcements like these. All right. Today, we're going to be talking about what's called data modeling. Now, the reason that I say it's called data modeling is the way that I call this chapter is I call it UML diagrams, and we'll find out why that's the case here in just a second. But sorry, I'm trying to write something down. My pen's not working. Anyway, remember when we talked in chapter 2, we talked about two different diagram types. We talked about activity diagrams or activity models and structure models. And activity models was the focus of the last one. And the way that I kind of delineated these is I say, the activity models represent the system from a human perspective about how a human would characterize the system. And the way that we're going to be representing those moving forward in the course is we're going to be using business process model notation or BPMN diagrams. And so that was part of the process that we actually used. Now, if you thought we're done with chapter 2, I never have to deal with those diagrams again, I've got bad news for you. All right. You're actually going to deal with them again quite a few times because chapters 5, 6, and 7, we're going to get into business process areas. And a big part of that will be diagramming those business processes. So you will have to remember the things you learned in chapter 2 for future chapters. For this chapter, we're going to talk about a different form of diagramming. This is going to be referred to as structure diagrams or structure models. And this is how I refer to a process that from the computer perspective. And our use for this is going to be something called UML diagrams, which I'll explain here in just a second as to what that represents. All right. So structure models at basis level is basically saying that describes entities or things that are in the domain of interest and the relationships among those things. Now, that's really, really basic language right there, but these represent the two most important characteristics of a structure model. Want to know what is the entity and what is the relationship between individual entities. So the entities that we're describing, and by the way, when I say entity, I'm not referring to like an organization or a business. Entities are basically different in context for this particular type of diagram. An entity can be anything that represents a resource, event, agent, or concept within the organization. Trust me when I say it'll become a little bit more obvious as we get into it. But I wanted to make sure that clear when I say the word entity, I'm not specifically saying the organization you work for or a customer or a vendor. We're talking about something more kind of abstract within that term. So the entities and the relationships among those entities. We also want to specify how many instances of one entity can be related to one another and identify the attributes and characteristics of relationships. So what is the form that we're going to use? And this is going to be one that's going to be called UML or Unified Modeling Language. Now, I mentioned this in our first class period. This is the one area of this course that students tend to struggle with most, which is apparent, or it's kind of obvious as to why that should be the case. Because when we talk about business process model notation, that's human representation of a system. This is basically the computerized representation of a system, which we're not computers, at least not in the traditional sense. You might argue, well, we've got features like computers, Dr. Barnes. We've got storage and we've got processing. And I say, yeah, you know what I mean. Okay, quit being technical. So we are going to be dealing with UML diagramming, and I do think it's important to have a working knowledge of this because you will encounter this in other courses and in other areas of your career. So trust me when I say that this will be something that 90% of you will look at and you'll say, I hate this with every fiber of my being. And I'm going to be like sympathetic. I get that. Okay. But it's really important to understand both sides of the coin. The best advice I can give you is to take UML diagramming seriously. There will be questions on the exam about it, and you will be expected to know this at a fairly strong level. I'm not going to go into super detailed analysis. If I really wanted to frighten you, I could say, here's the kind of UML diagramming that they expect you to know for college courses at the graduate level. I call this, where is it? I've got an image of this that I shared just for context. This was my first exposure to UML diagrams. This was about 4 years ago, all right? I did a presentation where somebody wanted to say, all right, here's what a UML diagram should look like. And I'm like, I never want to do UML diagrams. Trust me when I say that the UML diagrams can get this complex, but we will not reach this level of complexity in this course. So if you're just kind of like saying, all right, you've really, really dissuaded me, Dr. Barnes, this is to say, this is where it can be in the real world. We're not coming anywhere close to that. Okay. So just so we know what the context is. Anyway, UML basically employs class diagrams to describe the logical structure of a database system. So we're concerned about what does the system itself look like with respect to the technical representation of the aspects of the system. All right. So that's going to be the important thing that we need to note as far as moving forward with that. It is also maintained by the Object Management Group, which you may say that sounds really familiar, Dr. Barnes. What Where did that come up with? And remember, we talked about this in chapter 2. This is the same organization that maintains the procedures and policies for business process model notation, or BPMN. So same group maintains for both of these. All right, so what is it that we're going to be talking about? Well, let's go through the basic elements, and then we're going to talk about how we put these elements together to come up with a UML diagram. And I want to note, when we talk about UML diagrams, I am going to go into a little bit of depth on this, but I'm going to be very specific to say, make sure you know this. And when I say something, make sure you know this, you should highlight this in your notes saying, this is an area of focus. It's not to say that other information is not important, but the stuff that I say, make sure you know this, is absolutely going to be concepts that I ask you about on the exam. So the first thing that we need to note are going to be the classes, okay? The classes, these are items that represent about what the organization wants to collect and store information. And there's a lot of different ways that we can represent classes within an UML diagram. The way that we're going to use it in this textbook is going to be the class symbol with the name only for the most part. Now that goes to say that we're going to look at a few examples of how UML diagrams can be represented in other features, but we're going to keep it at a pretty simple level for this course because I'm not an expert in this and I don't expect you to be experts in it. That being said, when we use the term class, effectively that is what I was calling an entity. It's anything that an organization wants to have information about. A class or an entity, I use those terms interchangeably. So what kind of things can classes represent? Okay. The answers are going to be resources, events, agents, and conceptual structures. Now, I want you to remember those first three because we're going to take a very, very close look at those first three in detail. We're going to talk about the last one. The last one's kind of an afterthought, but the first three are absolute pieces of knowledge you need to know. So resources, trucks, buildings, machines, cash, investments, anything that you would think about, something that's used to generate assets or generate revenue for an organization, the resources. The events are basically items that relate to business. So sales, purchases, cash disbursements, cash receipts. Anything that you would traditionally think of as an accounting event. And the agents, these are the people who are involved and the individuals that are involved in those. So customers, vendors, employees, those can all be examples of agents in a transaction. Now, I want you to remember this. You don't need to remember the long list of each of these examples. It's fairly intuitive once we start getting into this. We're going to think about these at a fairly high level, but I do want you to make sure you hold at least this in mind, is that our class diagrams are going to be primarily devoted towards the relationships between resources, events, and agents in a business process area. And we'll talk about that in context here shortly. Conceptual structures I do want to talk about. Conceptual structures are a little bit confusing. And basically the way that we define conceptual structures are anything that provides clarification between relationships in classes. So when we talk about conceptual structure, I want to go back to a very simple example here in just a little bit. Think about it as we don't have an identified relationship between two of the entities or two of the classes in a diagram, but maybe we can actually present a relationship between those, okay? So we can gather information or provide information about relationships that don't currently exist. Hold on to that one because that one's the most confusing, but it is also the one that's the least frequently used. Then we have associations, and I've already alluded to this. This is basically the relationships between those classes or those entities. So you can kind of see the example that's given in the book, all right? Classes are going to be represented by the individual that are associated in a purchase of a vehicle. So this is kind of the example that's given in this diagram, okay? A person owns a vehicle, or I guess servicing a vehicle, not the purchase, but person owns an automobile. So there's two entities, two classes in this. There's the person, okay, which would be an agent, the automobile, which would be a resource. What is the relationship between the person and the automobile? The person owns the automobile. What about the dealer in the automobile? In the case of the service, they're the ones who provide the service on the vehicle. Those are again the two classes. And then automobile is going to be licensed in the state. So this kind of shows what the relationships are between each of the entities that we might represent within our class diagram, within our UML diagram. All right, one of the most important things we need to be able to represent in UML diagram is something called multiplicities, all right? Multiplicities represent the minimum and maximum number of times instances in one class can be associated with instances in another class. These are really confusing, but really, really important to understand. Now, I want to talk about the very most important thing that you need to remember, and I'm going to reiterate this multiple times throughout the course because this is confusing, but it's really, really important to remember. When we think multiplicities, what we're going to do is we're actually going to talk about multiplicities from the far end to this point. So when I'm basically, I say this, I say, okay, when we say a multiplicity, I want to start with automobile, and I want to say automobile is owned by one person and only one person. So you can see each person owns a maximum of 0 for the autos, but if I start with automobile, I say the relationship goes to this multiplicity over here. So the multiplicity that starts with whatever entity, when we start with a certain entity, we go to the far multiplicity. So if I say I'm going to start with automobile and determine what the relationship is to a person, okay? I'm going to say start with automobile, go to the far multiplicity, and define that relationship according to the other entity. So automobile is owned by one person and only one person. You can't have multiple people saying they have ownership of the same vehicle. I mean, I know you could argue that point. You could say, well, what if it was a couple? It says, well, then we start getting the legal issues where two people own the vehicle, but in the eyes of the law, they're seen as one individual. And so not getting down into the hairy details, we're just going to say 1 and 1 is their multiplicity. Similarly, we could say a person could own 0 automobiles. Like, if you're younger, you probably don't have your own car yet. So I have 0 automobiles, or you could have some people that own multiple automobiles. Multiplicities are indicated by one of 3 different characters, okay? They're represented by 0, 1, or a star, which that star means more than 1, basically. And the way to interpret multiplicities is a little bit challenging. So first of all, you will notice that our relationships are depicted on both sides. We actually depict the association both directions. And again, whichever one you start with, you go to the far multiplicity. So a person could own 0 multiple automobiles or could own many automobiles. That's how we interpret that. What are the possible permutations of multiplicities? Well, I was working on this in my previous class because this is in this classroom, and I wrote this down on the board, okay? And I deleted out my camera because I realized there's no point in having the camera up. And so I just, because there's no point in having the camera up while we're going, so I'm going to show the video panel. So, okay, video panel over. I don't know if this is going to be transposed on YouTube. I think it is. I think you'll actually see. But this is actually a diagram. So there are 5 possible permutations. You may say, Dr. Barnes, there's 6. What about 0 to 0? I say, if there's 0 to 0, there's no association because there's no relationship. You can't own a 0 and a minimum of 0 and a maximum of 0. Okay, so we're going to ignore 0 to 0. We have 0 to 1, which is basically saying a minimum of 0 and a maximum of 1. So a person could have 0 meals of breakfast a day, but a maximum of 1 meal of breakfast. Now, if you're a Lord of the Rings fan, you may argue, what about second breakfast? And I'm going to say that's a fair argument. But we're going to assume we're hobbits, or not hobbits, we're humans, okay? We only eat 1 breakfast. We have 0 to many, okay? 0 to many. And then 0 to many says, okay, 0 customers. A customer could have 0 orders or many orders. You may say, what about a customer having 1 order? Says, well, a customer could place an order and we could refuse to actually meet that order. So they place an order, but we don't actually fulfill the order. So a customer could have 0 orders placed, or they get many orders, which is commonplace for many customers. They go to a place many times. Then we have 1 to 1, which is basically a minimum of 1, a maximum of 1, which we just looked at as car to owner. Okay, a car has a minimum of 1 order, a maximum of 1 owner. Then we have 1 to many. Okay, instructor has to teach at least 1 course. If they teach 0 courses, they're not by definition an instructor because they're not instructing anything. So instructor has 1 course, but it could teach many courses, as most of our instructors do. And then we have many to many. Okay. A course has to have at least a few students. It can't have 0. It can't have just 1. It has to have multiple students and a maximum of students. Now, again, you can argue at this. Like if you're taking an internship and maybe saying like, I'm the only person enrolled in this internship course, and I say, you know what, you're defeating the purpose of my illustration. So stop throwing examples. And I know I'm the one doing that, so I should probably tell myself to shut up. All right, but these are some examples. Now, a few things to note. The multiplicities always work from the smallest number to the largest number. You notice we don't have 1 to 0, okay? Because the one on the left represents the minimum, the one on the right represents the maximum. So we can't have a 1 to 0 relationship. That just won't work because you can't have a minimum of 1 and a maximum of 0. And we can't have multiples of the same because we have 1 to 1, we have many, but we can't have 0 to 0. By definition, there's no association of the 0 to 0. Now, you don't really need to memorize this because it will become obvious how these multiplicities work. And we're going to look at a bunch of examples of how to interpret multiplicities. But right now, I just want to kind of explain how multiplicities work and the type of thinking that you should utilize when you think of these, because this is an important element. All right, I'm going to blank out the camera again. A good intention right there of hiding the video panel and then just not have it. Yes?
Can the star ever be like a different number, or does it have to be something?
So basically, if it's greater than 1, then you just say the star, okay? Now, there may be some rare circumstances where it always has to be a certain number, but for purposes of UML diagram, we just say anything greater than 1 is considered. Excellent question. All right, then we have attributes. Attributes are data elements that describes the characteristics of a class, okay, or records. So when we think about records, records represent each individual instance of a particular class, whereas you can actually say each class has certain attributes. Now, we've already experienced this. You've seen this many, many times. Because when we talk about records and we talk about the individual classes or the individual entities we want information about, each of those entities tends to have certain attributes about them. Think of the example we looked at on Friday when I actually showed you the individual students that are in my fictitious class. Each of these banner IDs represents an individual record, but each of those records has different attributes for each of the instances. So for the first banner ID, they have a unique last name, a unique first name, or quote unquote unique amongst those 6 records. And then middle name, email, all of these represent attributes of that particular record. And those attributes change for each individual record as we present. So the full specification of attributes is going to be in a data dictionary, would include the data type, the default values, and the constraints on the values, which are going to be the minimums and maximums, and other descriptive information. In other words, if we were to do a full analysis of a table, we not only want to know what this information is, but what it represents. Some of this is fairly intuitive. If you see the word email and you see a whole bunch of addresses, you're like, oh, that's obviously the email address, okay? But what if I have like a pay type and then I have letters listed below the pay type? Is that necessarily intuitive with what pay type means? You can say, well, Dr. Barnes, I live in the real world. I know there's salaried and hourly. What if I say Pete? What does that mean? You say, it means part-time. They're like, you have to actually have definitions of what each of these attributes is. So that's what the data dictionary entails. It talks about the possible default values, the constraints on the values, but most importantly, what the types of data are and how they should be interpreted. Okay. We're going to talk more about this next week, but I also want to lead into something called primary keys and foreign keys. And trust me when I say these are really, really important for database building. If you've taken a database course, you probably already have familiarity with this concept. But the primary key is basically going to be an attribute or a combination of attributes that uniquely identifies each record. Now, there's some important rules that we need to identify, and we're going to reiterate these rules again next week because we talk about this again when we get to relational databases. But the primary key cannot be a null value because by definition, it can't be unique if it's a null value because multiple different records can have that same value. And it should also be controlled so it'll be changed over time. They'll not be changed over time. Should not be changed over time. So let's just really quickly think about a primary key. Does everybody in this room have a primary key in the Truman State database that contains your student record information? What do we call that primary key? The banner ID. Yeah, everybody has a unique banner ID. Now, we might want to say, what about our names? Interestingly enough, I have had students with identical names. Identical names. There's one story about a student with a name, and there was a student with the exact same name, first and last name, but one was male and one was female, and they could not have been more different as far as their physical attributes. One was, a former Marine, very, very tall and very burly. Another one was a short, petite young lady who was very, very smart, but it was very interesting that they shared a name together. So that's kind of a clue that names cannot be primary keys because they're not unique identifiers. That's why we have the banner ID. Now, this leads to an interesting point because why do we have banner IDs? And the answer is that we ought to be able to identify information that's contained within one database, but we also want to be able to match that to other database information. This relates to something called a foreign key. This is an attribute or combination of attributes that allows tables to be linked together. So if you were to go to your Truman State database, it would probably say your banner ID. It would have your name information. It probably would talk about when you enrolled, what your birth date is, your address, things along those lines. Now, when I get that information, remember when I was talking about this information, I have a banner ID with some ancillary information. What am I using your personal information for? And the answer is that I'm identifying you so that I can assign you a grade in this course based on your performance. Is that information that would be contained in the Truman Master Database? Do they care about what you scored on your third homework assignment in this course? Probably not. But if I want to be able to return information to them, they need to have a way to uniquely identify your performance in this course. At some point, I'm going to return and I'm going to report, and I'm going to say banner ID number 1 got an A, banner ID number 2 got a B, so on and so forth. That is what the foreign key is used for. It's for external resources, which is not necessarily going to be the primary identifier that can be used to match back to the original data. So we're going to see a lot of that. One thing to note about a foreign key is a foreign key is always going to be a primary key or a combination of primary keys from another table. That's how we match that information back. All right. So some notes about primary key assignments. Should you use your no social security number as primary keys? The answer is no, because not everybody has a social security number. So the number could be null, and that would not be a unique identifier. What about people's names? We just talked about that. No, not a good idea, because people can have the same names. Sometimes it's identical first and last name. What about phone numbers? Phone numbers change over time. I shouldn't say that. I shouldn't say it's not as common. It used to be very common. When I was growing up, it used to be like I had a different phone number every 5 years or so. Now I've had my same phone number for going on 25 years, which can change. But it's still possible your phone number can change, particularly for landline phone numbers. And then what about your site primary keys using sequential numbers? And that is a good idea, because that actually allows us to identify gaps and we control and control the number. So your banner ID is often a representation of your sequence that you enrolled in Truman. If you compare that to somebody else's banner ID and say, wow, that's a much lower number, you must have been at Truman State much earlier than I was there. And the answer is probably correct, because it's sequential assignment. So that way we can identify gaps. As we know, gaps can be problematic, because if gaps are occurring, we want to know why they're occurring. But we're not going to talk too much in depth about that. That is something that we could talk a little bit more when we get to auditing later on, or if you get to some other courses that talk about computer anomalies, that would be something that would be very, very important to be able to track. All right. Let's go ahead and let's start with kind of the prototype example of what I want to use in this course. All right. So the basic UML presentations course, by the way, remember I said I was going to say this is really important. This is one of the slide that I think is the most important presentation slide in this entire lecture, okay? This is going to be the basic presentation format for this course. The reason I mentioned that is we're going to do a deep dive here in just a second. That is going to be informational, but you will not be required to structure UML diagrams according to the way that they're structured here in the next few slides. Our structure of presentation for this course will be just like this. And this represents a few very important things. I know this looks really, really simple. It's like, Dr. Barnes, I got it, move on. No, all right, because I want to make sure that everybody's clear on what it is that's being presented in this particular diagram. This seems like a really simple one, and it is, but there's some very, very critical points that have to be made. First of all, you will notice that I put some titles over the top of the diagram: resources, events, and agents. For every diagram that you present in this course, every UML diagram you present in this course, you should structure it exactly that way. Resources on the left, events in the middle, agents on the right. Now, as we're going to see as we move forward, our events tend to be what drive these relationships or drive these diagram creations. But we're actually just going to present it with the resource on the left and the agents on the right, so we can kind of segregate those. So remember, resources, events, and agents, these are our 3 primary classes that we talked about before. You can actually make an argument that this is not an UML diagram, this is an REA diagram. You will actually see that terminology in the literature if you do enough review. They're basically the same thing for our purposes, but we're trying to actually depict how the resources, events, and agents interact with one another. All right, so the next thing we need to note is that, like I said, this whole relationship, this whole diagram is being depicted by one event. It's going to be an AIS class session. Okay, that's the event that drives this. Because if we have no AIS class sessions, there's no point for us to all have a relationship with one another. All right, we're all going to be in an AIS course, and so the AIS class session is the event that drives this particular course. So AIS class session is our event. What happens during an AIS class session? I give you a resource. I give you information. Sometimes that information is great, like when I give you information about how to build UML diagrams. Sometimes it's not so good, like when I give you discussions about Lord of the Rings and Second Breakfast, okay? But it's all information nonetheless. That's the resource that you're being fed in this particular situation. And then we actually talk about the agents that are in this. There's 2 different sets of agents. There's one, the instructor, and then there's the students out there. All of those represents agents, but we have different roles that we play. You as a student play a different role than I do as an instructor. Then we have to characterize what is being conveyed here. Now, the multiplicities are a little bit open to interpretation, but we can kind of depict those. By the way, just so you know, I'm not terribly static on multiplicities. If you can make a strong justification for multiplicities, I will give you credit for those. Oftentimes, though, I will be very, very consistent that you actually be able to interpret what a multiplicity represents. So if I present a multiplicity to you and I say, what is the relationship to this relationship? You do need to be able to interpret it. If I give you a narrative and say, based on the narrative, what should the multiplicity be? I'm looking for a particular answer. But if I just basically give you a diagram and say, use your best guess here, that would be a situation where you'd have open-ended interpretation of that. You just have to justify your position. On the exam, generally, it's going to be more about specific answers, but I will give you plenty of information to guide that determination. Let's take a look at this multiplicities and see if we can interpret what this says. So over here, information in an AIS class session, okay? So in an AIS class session, I'm going to give you at least one piece of information and possibly many pieces of information, a minimum of one and a maximum of many pieces of information. Now you may be arguing, you say, Dr. Barnes, this is AIS. It's certainly possible you can give me 0 pieces of information. It's like, I'm gonna chop that off and say, I would not hold a class session if I had nothing to teach you, okay? So 0 is not the minimum multiplicity here, all right? Now, on the other side, information can be taught in at least one class session, all right? This is, again, relevant information, relevant resources. If you say it could be taught in 0 class sessions, I say it would not be relevant to this course if it was 0 class sessions, so I wouldn't include it in the diagram. So information can be taught in one class session, but I could also teach it in many class sessions. For example, we're going to talk about UML diagrams in this class session. We're also going to talk about it in the class sessions for Chapter 5, Chapter 6, and Chapter 7. So we're going to talk about it multiple times, the same concepts. So information can be made multiple times. Does that sound like a reasonable interpretation of the UML diagram? Yeah, I hope so, okay? Could you make an argument that there's different interpretations of that? Certainly, all right? This is not, again, static where I'm saying that you have to actually have the absolute answers here. If you want to make an argument that information is not covered, could be covered 0 times, I do open interpretation of that. Hopefully I cover all the relevant information for this course. That's what I'm testing you on. But maybe you point out in the exam, says, Dr. Barnes, this was on the exam, but you never talked about it. And I said, I got to update that UML diagram now, okay? Hopefully I'm not testing you on things, though, that I don't teach in class. So that's how we interpret the multiplicities here. And then, of course, just make sure that we actually are clear on the associations that we actually can identify. You will notice these are not verbally depicted. We don't actually be able, or actually be able to represent what these are, but hopefully you can actually determine what the representations are. AIS class session is being taught by the instructor, is being learned by the students. Information is being taught in the AIS class session. The associations are there. They're not explicitly defined, but you do need to be able to define what those associations are if you were to do a narrative depiction of these particular diagrams. All right. So this is a simplistic model, and we spent a lot of time just talking about the simplistic model. How much more in depth can we go? And the answer is there's actually quite a bit more depth that we can go to. The most important thing from today's lecture is going to be the last 5 minutes I spent talking about this particular slide. You should know every single little detail of what we just talked about. You should be able to interpret that very, very well. And trust me when I say, in the past year that I've been teaching this particular version of the course with the UML diagrams, this is the area that people have struggled the most, is this particular concept. So if it seems like I'm harping on something really, really simple, it's because when I ask this really simple series of questions on the exams, people miss them, okay? So there's a very, very big reason why I'm spending so much time talking about this over and over again and repeating myself, doing a mini relationship, because I have to talk about this many times to make sure it gets embedded. Going into a little bit more depth on some concepts. Now, this comes from a different source, but I still think it provides some value. This is a different representation of the UML diagrams. If we go back several slides, remember, we talked about the way that these can actually be presented. We could actually have class symbols along with attributes and operations presented those. These are expanded UML diagrams. I want to specify this is for informational purposes only. You do not need to prepare your diagrams according to what we're about to look at. I just want to clarify what kind of information can be depicted in diagrams and what that information represents. Okay. So additional information that can actually be presented is we can actually say stereotype. Okay. A stereotype would actually represent the class type. So remember class types, we said there were 4 of them: resources, events, agents, and conceptual structures. We could actually clarify that within the ARIA or within the UML diagram, we want to also specify what is the class type. The reason that we don't do that in our version is that these are fairly intuitive based on where we put them within there. All right. Now that does lead an interesting question, and I want to jump back real quick because I meant to talk about this. Only 3 of our class types are talked about here, but we had 4. All right, we had 4. What was the 4th again? It's conceptual structures. Could I put a conceptual structure in this? The answer is yes. The question is, where does it belong? Because it does not meet the answer for resource, event, or agent. The answer basically is wherever there's room. Okay, once you've filled out the UML diagram with the necessary resources, events, and agents, if you want to represent other relationships, other structures, other entities and other relationships, then you can put them anywhere in the diagram. You do need to be clear when you actually depict them that this is not something that's a true resource, event, or agent. This is a conceptual structure. All right. That's why these diagrams are a little bit minimized in the fact that if I put a conceptual structure right here, you can say, oh, that's a resource. And I say, no, I'm just putting it there because it doesn't fit within any of the 3 categories. What would be an example of a conceptual structure that I'd use in this diagram? Well, is there information that the instructor the information is there certain information the instructor what's the word I'm looking for puts together over the course of the semester about the students. So there's a relationship between the instructor and students. Let's put it that way. It's an easier way to depict this. What information do I gather about you during the semester? Give you hints. A, B, C, D. What are those called? Grades. Okay. I gather grade information about students over the course of the semester. Is that a resource? No. Is that an event? No. Is that an agent? No. Is that a relevant association between the instructor and students? Yes. Okay. So if I wanted to gather information about you, I could say, all right, I want to gather information so I can determine grades for students. There would be an association. An instructor assigns the grade, a student receives the grade. So if I wanted to add another UML or another piece of UML diagram, I might throw it over here where I say grade book would be a conceptual structure. Now, that's kind of in addition to that, most of our examples will not use conceptual structures, but you do need to be prepared to see those. Again, it just depicts additional relationships that are not contained within the primary UML diagram. All right. Then we have our class name. It assigns the name to the class item. This will be pretty straightforward. Our class names are going to be given in our UML diagrams. That being said, I'd say it's more important to be able to interpret what the stereotype is as opposed to what the class name is, because the class names are often different. Next, we have attributes. Now, our attributes, as I said before in our simple diagram, they will not be defined. You will just have to draw an arrow. That being said, if I ask you to provide a narrative of a UML diagram, you should be able to depict what that association represents. So like I said, the teacher teaches the AIS class session. You should be able to understand that an arrow from AIS class session to instructor represents the teaching that goes on in the AIS class session. So that'd be an example of that. Attributes. I'm talking about the associations. Let's talk about the attributes, the key characteristics of each class. So this would be an example of, I got a little bit ahead of myself. This would be an example of what kind of characteristics are for each entity. This will not be contained within our simple diagrams, but if we were to actually present this within what we've presented within the table in a computer system, whether it be an Excel diagram, an Access diagram, or even when we start working in Power BI a little bit later on, these are going to be attributes of each of these entities, the entities that are going to be represented for each one. So for a customer, you might say, this is going to be customer ID, the name and the address. We've already looked at examples of these, because I looked at my examples of students that are in the course, my students from last week. I say students have a banner ID, they have a name, they have a email address. All of these represent attributes that will be presented within the actual table that presents those entities. Okay, associations we just talked about. Primary keys, those are uniquely identified records in each class item. You will notice that it specifies a primary key as a customer ID, which is similar to the banner ID we set for students within the course. And then the foreign keys are multiplicities. These are the minimum and maximum valid values for an association. Again, the interpretation starts here and moves over. So a customer can be involved in 0 sales or many sales. Again, why is that number 0? Well, if the customer says, I'd like to purchase from you, we check the credit of the customer and say, this customer has bad credit. We are not going to do business with this customer. They still are a customer because they've requested an order, but we've not actually fulfilled any orders with them. Therefore, no sales. In more likely scenarios, we're going to say, hey, great to do business with you. We'd like to do it again. And we have customers come over and over again, so they do business multiple times. Okay. A sale involves one customer and only one customer. Usually that's going to be the case. In fact, in most scenarios that I can think of, you can make an argument for some fringe scenarios that involve multiple customers, but that's very, very rare. All right. There are some information about other notation here. I'm not going to test you on this. This is mostly, again, for informational purposes. Most of the information that we're going to be concerned about with respect to UML diagram is contained within the first the slides that we looked at before, and the core attributes of these the core attributes of each of the UML models that we've looked at. But in order to move forward, I do want to talk about the last part of this particular chapter and talk about decision making. Now, this is a little bit ancillary, and this is probably the least important point of this part of this particular chapter. But I do want to talk about it, that it does relate to how we utilize information within our decision instruction models, activity instruction models, for decision-making purposes. So analysts must recognize decision-making requirements, establish business rules to support these requirements. So what are the 4 steps that are going to be used in establishing decision-making or establishing decision-making requirements? I'm losing the ability to talk, guys. I'm sorry. Identify decisions required in the process. Describe and document these decisions and how they impact the business objectives for the process. Specify decision requirements in terms of the information and knowledge required to make decisions, and decompose and define the requirements, determining where existing business rules apply and where business rules need to be developed. That's all well and good. I don't think it's important to memorize what the protocols are for setting up decision rules. I know I listed them out, but most of this is fairly intuitive. If I were to ask you, what is the process for making a decision? I think you could identify some variation of what's listed up here. What's more important is, what types of business rules are we going to be subject to? And this is where I think it becomes really important, is to identify, all right, when we are operating a business, what type of rules are we subject to based on the nature of the decisions? So the first is going to be an obligatory business rule. And this rule form states what should occur, what the situation is. An example would be payment should be made in US dollars. But payment is not made in US dollars, it violates that business rule. Okay, so obligatory basically sounds this is an obligation they have to meet, just as the stem from the word. The second business rule is something's prohibited, which is just the opposite. It's basically saying this is something that cannot occur, that should not occur. No payments by check. So you're operating in business and somebody pays by check, says we can accept that. That's a prohibited business rule. That's a definition there. Now, you may say that these are basically the same thing. They're just the contradiction of one another, but it's important to specify what can and cannot occur, because sometimes there will be room for clarification. So if I say payment should occur by US dollars, payments must occur by cash or credit card, and say, oh, so can you accept Bitcoin? It says no cash or credit card. Can you accept check? There's enough room for that clarification. So we need to have business rules to say what can and what cannot occur. And then finally, we have allowed. This form says what is allowed under certain conditions. Credit card payments are allowed if the card is American Express. So this is a little bit different from an obligatory business rule. An allowed business rule states that this is something that can be obligatory if certain conditions are met. So you have to specify what the conditions are in order for an allowed situation to be met. The reason this is important is because if we meet the condition, it's an obligatory business rule. If we don't meet the condition, it's a prohibited business rule. So the specification of what the criteria are critical in that particular situation. All right, so our decision tables, we're not going to look too much at this, but we do have some examples of this in the homework that I want to say. Decision tables consist of some information that we need to be aware of. First of all, what is the name of the decision? What are the set of inputs that we're going to be looking at, as well as a set of outputs and a set of rules? So the rules are going to be defined according to like the records within the table, and each of the rules are going to be specified according to which record is going to be listed. The records will be characterized, the attributes will be listed as a set of inputs as to what the customer type is, a size of order within this example. So those are going to be the inputs that we would want to look for in order to make our decision. And then the outputs will be saying, based on what the inputs are within a particular scenario, what is our result? So if we have a business customer with an order of less than 10, we offer them a 10% discount. If we still have a business customer, but it's greater than 10, which is a different condition, we give them a larger discount. We give them a larger discount based on the size. So once we know the first two inputs, we can determine what the output should be, which would be the item in the third column. So think of this as a spreadsheet. Think of this as how we set this up. And we have an if statement listed over here and be looking for conditions over in the situation. Once we actually specify what the conditions are, it'll provide a result to us based on those conditions. And that would be a fairly complex if statement to write, but that's an easy way to think about how the output comes out within a tabular system. All right, I believe that's plenty to go through. Please make sure on your homework, especially for the stuff that requires UML diagrams, that you take that seriously, because this will be information that you're tested on. So it's good to get in the practice now and try to do your best to make sure you understand the interpretations. I will see you all on Friday for Excel and check with your homework. Have a good day.
Not really. Yeah.